Good morning, welcome back. Today we're going to enhance our knowledge a little bit more about how planets move through the universe. Now we've already talked about the organization, that we have a heliocentric model for the universe and that the sun is in the center with the planets revolving around it. But previously, we only knew that we thought the sun had those planets orbiting around it in perfect circles. But over time, scientists discovered that wasn't true. Johannes Kepler, an Austrian mathematician, is the one that realized that the orbits were a different shape. He realized that they were elliptical patterns based on the movement of Mars. Now, if we look at the basic ellipse that makes up these patterns, there's two key locations we need to know about. The perihelion is closest to the sun, and the aphelion closest, to the end of the orbit. So the aphelion is furthest away, the perihelion is the closest. Those words are going to help us when we discuss the location of the planet and the way that the orbit is behaving. Now, Kepler is most famous for his three laws that dictate the planetary motion, and this includes satellites in space around Earth, the moon around Earth, and all of the planets around the sun in our solar system. So the idea is, if we look at this orbit, we have our sun and any given planet. His three laws state that the first, all planets go in this elliptical pattern. That's pretty straightforward. We know that a planet is going to create this with the sun at one axis and the planet traveling around the sun in an ellipse. Note that the sun is not in the very middle. Instead, the sun is at one focal point. So if you cut the ellipse in half, it would be in the center of one side, and the planet will go all the way around the full ellipse. His second law has to do with the speed of the planet. Now, what you'll see here is that we will revolve in certain chunks. The chunks that are further away from the sun, the planet is going to move slower. So that's why here we have further equals slower. As it gets closer to the sun, it will move faster. So closer equals faster, further equals slower. So you're going to note that it's kind of like a slingshot effect. It's going to go slow, 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 then get pulled and whipped around. His third law states that the closer a planet is to the sun, the smaller that its orbit's going to be. For example, if we have the sun here and a planet here, you're going to see this elliptical orbit. However, if the planet were to shift in, the orbit would become smaller and closer to the sun. Now again, we have three laws that Kepler designed. The first, all planets orbit the sun in an elliptical orbit. The second, the closer the planets are to the sun, the faster they're going to move. The further away, the slower they are going to move. And finally, the closer an overall planet is to the sun, the smaller its overall orbit is going to be. Now, as you move forward and finish up your notes and you study your vocabulary, I want you to consider what the driving force of all of this could be. It's a topic that we've already discussed and something that we're going to investigate together in class.